So let us just talk about what we mean by vertical. I say vertical, what does that mean? Or horizontal, what does that mean? Okay. So the vertical axis, the Earth is a sphere. At any location on the surface of Earth, the vertical axis is defined by the line that's anti-parallel to the gravity force. So if you let anything fall, that direction defines the vertical. The horizontal plane is just the plane that is perpendicular to the vertical. Okay, we call it the local vertical. So in a fluid at rest, the gravity force that you have is balanced by an opposing force, which is the vertical pressure gradient force. Okay, so if you switched off gravity, all fluid on Earth would just jump into space. Okay, so it's the vertical pressure gradient force that operates opposite to the gravity force. And then you can think about it, and clearly what it implies is that in fluids like the atmosphere and the ocean, the pressure has to actually increase with depth. Okay? In the atmosphere, the pressure has to decrease with height. And this balance is called the hydrostatic balance. Again, the hydrostatic balance. And it's actually in fluids is a pretty fascinating feature because you can actually relate vertical pressure gradients to the density field. Okay, and this balance actually gives you a link between the properties of a fluid and to the dynamics, because horizontal pressure gradients actually create currents in the oceans and winds in the atmosphere.